Hi, thanks for joining me today. This is Gary Zacharias, and this is the Apologist bookshelf. I'm going back to one of my favorite authors, Hugh Ross. He always makes me think. He actually did this book with Kenneth Samples and Mark Clark. It's called Lights in the Sky and Little Green Men. It was put out quite a while ago, but it's subtitled A Rational Christian Look at UFOs and Extraterrestrials. And if you've been interested in UFOs and been a lot of current sightings and all sorts of interest in that, you might like taking a look at this book. I've done a couple of podcasts on this same book before. I wanted to look at chapter 4. It's called Life on Other Planets. And they start off, I say they because it is 3 authors, but Hugh is probably the primary author. But he talks about what a wonderful alien was in E.T., and he said, "E.T., phone home." But they said, if extraterrestrials are really visiting Earth today, which is what a lot of people believe with these UFOs, then where's the home that they would phone to? In other words, here's the question for the chapter. Are there lots of places in the universe where life could exist? Now, there's been an optimistic answer for a long, long time. Yeah, sure, they're bound to be there. So they said the films like E.T., and then there was Carl Sagan's Contact, and it said, of course, based on naturalism, the idea that there's nothing beyond this world, there's no God, no demons, no angels, nothing supernatural. So it said, if you've got that world of naturalism, you're pretty well setting the public up to think that life is all over the heavens, everywhere. So he said, let's look at the challenge for this chapter. Is there a place in the cosmos that a real and physical ET could call home? He said, well, we have to think of 3 issues. Number 1, the number of planets that are all out there all over the universe. Number 2, the probability that any given planet would have the right characteristics to support life. And 3, the availability of sites other than planets where life might reside. So they're going to look at all 3 of these. So number 1, how many planets do we have? Well, he said a few years back, astronomers were divided. Some felt that planets were just around almost every star in the cosmos. And then there are some that said, no, the sun's probably a rarity to have planets at all. So I said, what's happened, though, in science in the last few years, it's moved astronomers to deciding there aren't as many as we thought. Oh, so I said, instruments, we've got better instruments now to detect planets, but not a lot have been found. And while sophisticated theoretical models have been developed to say, well, here's how dust that turns into a disk going around a star could turn into a planet, but said they just don't support the conclusion that planets like those in our solar system are common. So it said, based on observation and theory, pretty much, it seems that solar system type planets really are not as numerous as we would think. Now, have they found some extrasolar planets? Yes. Now, by the way, let me go back and tell you when the book came out. That may make you think twice about this. It came out 2002, so we've had over 20 years. Now, I'm sure they found a lot more extrasolar planets. But it says, do the planets suggest that it's common to find planets that could sustain life? He said, well, what about the evidence? So in 1992, that was 10 years before this book came out, astronomers found the first extrasolar planets. All right, so they did find some. So it said in 1995, they found a gas giant, kind of like Jupiter, orbiting a star. Now it says when this book was published, remember this was 2002, they found 66 extrasolar planets. Now, of those 66, 1 is more massive than the Earth, 6 are about the size of Saturn, and the rest are about the size of Jupiter. So it said that gives people a growing appreciation for the rarity of a planet like ours, and gas giants, but not many like our planet. And so far, these planets that they found are orbiting young, metal-rich stars. They said that's no surprise. So it said the heavy elements that you need to make planets require at least a couple of generations of star birth, star death, and then the scattering of star ashes. So it said fewer than 2% of the stars in the Milky Way have enough heavy elements to produce planets that could support life. So look what he's saying there. 98% roughly of the stars are just too old and too metal poor. Now he says stars that have known to have planets, within that 2% group, none are as old as the sun. So none can match the stability of the Earth, sun, and solar system in a really nice circular, nearly circular orbit, not too elliptical. So the sun is special. As for the availability of life sites in other galaxies, so maybe we should look beyond the Milky Way. But they said the odds look bleak. It says, as it turns out, the Milky Way galaxy is exceptional for young stars. All right, so I think that's interesting. So observations, Hugh and the others say, indicate that maybe 0.1% of all stars have planets. That's their current idea. Now, I don't know if that's changed since this book came out, but they said that's a lot smaller than somebody like Carl Sagan estimated, because he had the idea that almost every star was orbited by planets, and so you'd have this monstrous number. But remember, what they're saying is about 0.1% of all stars. Well, that still makes a lot of planets, though, doesn't it? They said if each star that possessed planets had around 10, then the number of planets in our universe would add to 10 to the 20th power. That's 100 million trillion. Ooh, so then they said, isn't that exciting? Everybody thinks, well, if there's that many, there's got to be life. Okay, but then the next step, how likely is it that any of those planets offers a hospitable habitat for life? So Carl Sagan, back in the 60s, estimated something like 1 planet in 10 would have the right conditions for life. But that was in 1966. What has science told us since then? Is his inference still valid? It says, one time biologists speculated, well, maybe extraterrestrial life is based on some weird exotic chemistry, not on carbon like it is here. And if that's the case, you could just have life teeming, right? But biochemists quickly found out that the only elements other than carbon that you can get adequately complex molecules are silicon and boron. Well, here's the problem, though. Silicon can hold together a string of no more than 100 amino acids. That's way too short. You got to have strings a lot longer so you can have them fold and turn into proteins. Everywhere in the universe, what about boron? It's less abundant than carbon, so carbon will always supersede it. And here's another problem with boron. If you put the concentration of boron together, it's toxic to certain life-critical reactions. So a physicist named Robert Decay, I guess, long ago deduced if you want physicists or any other life form, they've got to be carbon-based. So that's a conclusion, right? So carbon-based. It said that permits scientists to come up with a big list of what characteristics you've got to have in a planet. They all have to fall within a certain limited range to be capable to support life there. And that's not just the planet itself. It's the right star that the planet's going around, the moon or moons that that planet has, the companions, planetary companions, and even the galaxy. And they said this list gets longer with every year of new research. So they said the current list is up to something like 140 parameters. Now, in other words, over 140 things have to be just right for life to get here. So let me share with you here. I'm going to go to the page where he's got some of these things listed. And it's grown since then, by the way. He said 140 parameters. Remember, the book came out in 2002. The parameters have only grown. So there's a remarkable amount of things that have to be exactly right for life to exist on any planet. So, for example, I'm just going to rattle off a few of them. Remember, there's 140. So here are some. You got to be in the right galaxy size. You got to be in the right galaxy type. You got to have a galaxy with the right mass distribution. The galaxy's got to be located in the right place. You got to have the right number of supernovae eruptions. You got to have the right number of white dwarfs. You got to have a number of stars in the parent star birth aggregate exactly right. The parent star has to be a good exact distance from the center of the galaxy. I mean, it goes on and on. The parent star has to be a certain distance from the closest spiral arm. The parent star has to be a right age. the right mass, the right number of metallic substances, the right color, the right kind of solar wind, the luminosity, and of course the planet itself has got to have an orbit that's inclined just right, an axial tilt that's just right, a rotation period that's just right, a certain kind of magnetic field. I mean, I don't want to wear you out, but it goes on. I'm only up to number 36, and I've skipped about 2/3 of them. Let me just give you a couple more. The planet has to have the right kind of magnetic field, thickness of crust, albedo, which is the way that it reflects light, and it goes on and on. It's just unbelievable. The right kind of atmosphere, and in the atmosphere you got to have the right amount of oxygen and ozone, the right kind of atmospheric electric discharge rate, the right kind of amount of water vapor in the atmosphere. So it's incredible. And you've got to have all those falling within a really narrow range if you're going to have the support of physical life. Well, it says those environmental requirements for life depend strongly on the life form in question. So if you have primitive life, then you don't have those parameters being quite so demanding. So that's a really good point to bring up. So they said, based on what they've come up with, a calculation of the probability for just one naturally occurring planet anywhere in the universe is outlined in Appendix B. Now, what's the chance? I won't take you to Appendix B, but they've done a calculation just to have one planet that will support physical life. It's less than one chance in 10 to the 174. What does that mean? Well, it's the number 1, and you follow it with 174 zeros. Okay, I'm just going to give you a second to have you think about that. 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, and on, 174. Now, I have no idea what that means. I mean, I know it's a large number, but Hugh and the other authors say if you want to get an idea of what that means, the entire universe has only 10 to the 79 protons and neutrons. Okay, so that's way more. So that's just to get one planet. That'd be like if you took every proton and neutron in the whole universe and you grabbed one and you painted it red and let it mix throughout the whole universe. You've got one chance in 10 to the 79th to find that one, right? Just to go around blindfolded in a spaceship and just point to one proton or neutron. But that's nothing. That's much easier to do than trying to find that one planet that's one chance in 10 to the 174th. Well, then they said, is it possible? Maybe there are other locations, right? So it says those statistics have just driven some scientists crazy. They can't come up with a possibility that there's another planet. So they said, maybe we shouldn't be looking for an Earth-like home. Maybe exotic life sites exist where life could exist in the universe. So, for example, what about a satellite? A moon that's going around a planet. Could life exist on a planet that's traveling throughout space instead of orbiting a star? Maybe that's another possibility. Well, before I tell you his answer, I want you to think about something here. Let's bring it back to 2025. If you notice, NASA has been sending out probes, and they've been really excited looking at Titan, which is one of Saturn's moons. They've looked at Enceladus, which is one of the moons of Jupiter, and they've wondered there that there may be an ocean, maybe there's primitive life underneath this ocean. So there have been attempts to say, okay, Jupiter doesn't have any life, Saturn doesn't have any life, but maybe it's the moons that go around them. So they said sometimes scientists are speculating that a satellite, some kind of moon that orbits a big planet about the same distance as the Earth from the sun, maybe that could be a life site. But they said, whoa, there are a lot of problems with that. So remember, they found 66 planets so far. Okay, it says none of them orbit their stars within a zone that would be required for life support. Okay, so large planets form under cold, low radiation conditions that are far from stars. So most planets will drift inward toward their stars. Okay, so that's good, but then they don't have a circular orbit that you need. So it said those 66 planets, most of them are having a high eccentric, in other words, a really elongated orbit, It's going to make life impossible. And it says a satellite orbiting close enough to its planet to avoid seasonal temperature fluctuations ends up being tidally locked. In other words, the same side always faces the planet. Now, what are you going to do? What's that going to do? You're going to have extreme day-night temperatures. So the satellite would have to orbit very close to the planet. But anything that does that is going to get all sorts of destructive effects. Climate instability, massive and frequent volcano eruptions. They said, just take a look at the moon Io, or Io, whichever way you want to pronounce it, that goes around Jupiter. Have you seen pictures of that? It looks like a pizza. It's got sulfur and stuff's exploding from the inside in volcanic eruptions. It's really amazing. Go on YouTube sometime and take a look. And it'll have orbital instabilities. So if you want to have a satellite, a moon going around a planet, it's going to get locked if it's too close to avoid the fluctuations there in the temperature. Well, what about a satellite without life-sustaining atmosphere? Isn't that possible? No, they said it'll lose it in short order. The planet is sending out charged particles from its magnetosphere, and it's just going to blast away any atmosphere. It says, for example, Jupiter's moon Ganymede has a really weak magnetic field, so water vapor clouds would never form. Well, here's one more problem. The satellite orbiting a large planet, trying to orbit it close enough that the planet's gravity would significantly attract asteroids and comets and all sorts of debris, and it's just going to get bombed into nothing good at all. So there's another problem with that. So they said, what about a starless planet? Isn't that possible? A planet just kind of wandering through space. So there have been a couple of scientists that said, isn't that a possibility? Maybe a planet doesn't need a home near a star. So maybe a planet could be ejected from a planetary system before losing any of its gases, and maybe it'd have enough surface warmth, interior radioactive decay, and maybe a heavy enough atmosphere it would sustain life, chemistry, metabolism. So they said, how does that hypothesis do? Said, well, this hypothetical life site might serve as a brief stopover for some kind of primitive extraterrestrial life, but it wouldn't last long enough within the life support range of temperatures and other conditions to end up with an intelligent ET there. And of course, a far-flung planet's going to have no protection provided by a nearby star and gas giants, so it's just going to get hit hard by comets. So they said that's an interesting idea, but ultimately fruitless, they said, for how intelligent life could exist elsewhere in the universe. So to wrap up the chapter, what are they saying? The bottom line, if ET has a home, it's got to be something like Earth, orbiting a star like the Sun, in a galaxy much like the Milky Way. See, years ago, I used to think, well, one galaxy is pretty much the same as any other. That's not true at all. There's some special qualities about our Milky Way galaxy that makes it great for life. And they said, ongoing research is showing that this is turning out to be less possible as each year passes. We're not finding Earths. We're not finding stars like the Sun. We're not finding galaxies like the Milky Way. It said, in fact, the number of known characteristics that have to be fine-tuned, remember I told you it's increasing? That's exactly what they said. Just from 1995 to 2002, those characteristics have more than tripled. But they said, meanwhile, the probability for finding a planet or another heavenly body anywhere that has the capacity to support life has shrunk by a much greater proportion. So they said ET does appear to be homeless unless, I like the ending here, unless a transcendent supernatural being built a home for him. So I think that's a really good chapter. So could there be life out there? It's just getting more and more bleak as far as that possibility. I read not too long ago that I think it was Penn State did a study of 100,000 galaxies. 100,000 listening with radio telescopes. Never heard a thing. Not a single thing. Does that mean there is no life out there? No. I mean, is it possible that God could create life elsewhere? Sure. But it's just kind of interesting. People that always say the Earth is just a run-of-the-mill planet going around a run-of-the-mill sun in a far-off section of the galaxy, that's actually not turning out to be the case at all. Isn't that interesting? Okay, well, I hope this was interesting to you. I love astronomy, and I hope you do too. There's a lot of good things going on out there that make us believe that there is a God who's interested in us and created a special place for our home. All right, well, thanks for being part of this podcast.